going on, guys? In this video I would like to uh, talk about some uh, resultant force acting on 2D diagrams. So there are some best questions I chose from mechanical engineering mechanics, so I'm going to explain to you one by one. First question is asking, determine the magnitude of the resultant force. Fr is equal to F1 plus F2 and its direction measured counterclockwise from the positive x-axis, and they have given the diagram right here. So first of all, I'm going to draw this diagram. So the free body diagram is going to be look like this, and here, 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 and the angle between them is 30 degree, and this force is F1 is equal to 250 pounds 250 pounds, and this is 45 degree, and this 30 degree, and they are asking us to find the FR and the theta, that the angle that makes the resultant force counterclockwise. So let's see what we can do from this diagram. So first of all, in this case, this is 45 degree and this is a straight horizontal line, so therefore we know this angle is going to be 60 degree, right? 60 degree, and therefore I can draw a parallelogram right here. So it's going to be like this, and if I draw a line that connects to this is going to be my resultant force. And in this case, this is according to the parallelogram rule, uh, each uh, each end should be made 180 degrees. So this is like 60 plus 45 is 105 degree, therefore we know this is 75 degree. So from this one, now I'm going to apply this in I'm going to use the cosine law to find this resultant force. So let's say cosine law is going to be what? Fr squared is equal to, so I'm going to just writing Fr because I'm going to write everything in the square root. So if I put a square root, this is 250 lb and this is 375 lb. So now it's going to be 375 square plus 250 square minus 2 times 375 times 250 cos 75. So this is the cosine law. um, that's a basic thing. I think you know that this cos 75 is opposite of this resultant force, that's why we use cos 75, and these two are each and each line that makes the parallelogram, so the middle one is going to be resultant force. So that's how we find the use the cosine law. Let's use the we need the calculator for this one, so therefore we have to use calculator. So calculate 375 square is going to give us what? 375 square is equal to 146,625. 146,625 plus 250 square is going to give me 250 square is going to give me 62500. 62500 minus 2 times 375 times 250 is equal to 187500. 187500 multiplied by cos 75. So first of all, I'm going to add this both of them together. This is going to give me 140625 plus 62500, which is equal to 2013125. 2031225 25 minus, and we have to find the cos 75. To find that, okay, let's see 75 cos, this is our cos 75, and I'm going to directly multiply this 187,500 with this 187,500, which is gonna give me 48528.6. So this is gonna be that, and let's see the root. So 20313125 minus 48528.6, which is gonna give me 154,596.4. So now I have to find the square root for this. So let's see. So if I square root this one, I get the 393.2 lb. So this is my final answer for lb. So now we have found the resultant force. So in order to find the angle, I have to use the angle between the resultant force and the x-axis. I had to use this in the sine law. First of all, I take the sine law here. Let's say this is theta, and if this is theta, sine theta over whatever the force opposite to this. So I draw the parallel. This one is parallel to this one, so it's going to be 250. Sine theta over 250 is going to be equal to 390. Sine the angle that makes opposite to the resultant force is going to be this angle, 75 degrees. So I'm going to use sine 75 degree right here. So this one is going to be sine 75 over this force 393.2. So in this case, sine theta is going to be equal to sine 75 times 250 over 393.2. So which is going to equal to what? So let's say 75 sine times 250 equal to this one divided by 393.2, which is equal to 0.6141. That's not that, 0.6141. If I inverse that, theta is going to be sine inverse 0.6141. 6141. So if I inverse this, what's going to come? So let's see. Shift sine inverse is going to be 37.9 degree. So theta is equal to 37.9 degree. We are not done yet. So first of all, with the angle, we found the angle theta. So in order to find the angle that will make with the horizontal, this resultant force that makes with the horizontal, I have to deduct this 45 because I have counted this with 45, right? So in order to I calculate that, I have to deduct this 45 degree to find that angle. So let's see, 45 minus 37.9, which is going to give me 45 minus 37.9, it's going to be give me 7.1 degree. 7. We are not done yet. The question is asking theta counterclockwise. So theta counterclockwise mean this is clockwise, right? 7.1 is clockwise. Counterclockwise mean it has to come all the way from this side to this side. So I have to deduct 7.1 from 360 degree. So it's going to be 360 minus 7.1, 360 minus 7.1, which is going to give me 352.9 degree, 352.9 degree. So this is my angle. So this is my force and this is my angle. So we are done with the first question. So if we move to the second question is asking, determine the magnitude of the resultant force Fr is equal to F1 plus F2 and its direction measured clockwise from the positive U axis. So in order to do that, I have to first draw the diagram. So it's going to be like this. So it's F1 is equal to 4 kilonewton and F2 is going to be 6 kilonewton. 6 kilonewton, and this is 30 degree, and this one is also 30 degree, and the angle that makes it 45 degree. So according to the angle law, we know that if this side is if this is 75 degrees, if this side is 75 degrees, this total size would be equal to 75 degrees. So therefore we know this is 30 degree, therefore this one is 45 degree. 45 degree. Now what I have to do is I have to make the parallelogram to choose the cosine law. So let's connect this one. Let's say this is our resultant force and parallelogram is right here. So now we are ready to use, so we had to find this angle opposite to the parallelogram, right? I mean opposite to the resultant force. So here we go. So the angle that makes that this 2 is going to be what? 45 plus 30, 75 degree. So see if this is 75 degree, according to the parallelogram, um, the angle that both sides should make, like two of the sides should make 180 degree. So if this is 75 degree, this one should be 105 degree. I had to deduct 180 minus, I had to do 180 minus 75, so it's going to give me 105 degree. So that's how I got this 105 degree. So now I am ready to use the cosine law. So cosine law is going to give me Fr is equal to square root of 6 square plus 4 square minus 2 times 6 times 4 cos 105. So if I use that, 6 square is going to be 36, 4 square is going to be 4 square is going to be 16, 36 plus 16 is going to be what? 36 plus 42, 52, 52, and minus 6 times 2 is 12, 12 times 4 is 45, 48, 48 cos 105. So let's see, 52 minus 48, I need the calculator for this one. So 48, 48 times cos 105. So I have to shift it and cos, no, let's see, let's calculate the cos 105 first. 105 cos times 48, which is going to give me 12.42. So negative 12.42, negative 12.42. So negative negative become positive. It's going to be 64.42. So let's calculate the square root of 64.42. So if I calculate 64.42 square root, it's going to be 8.03. So 8.03 kilonewton is our final answer. We are not done yet. The question, we have to find the angle right now. So the angle is going to be, to find the angle, I'm going to use the sine law. So sine law, sine theta, let's say this is theta, this side is theta. So if I take that theta, the opposite side is going to be parallel to this one, so it's 4 kilonewton, 4, and equal to, I have to use resultant angle and force. and resultant angle is 105. So sine 105 over the resultant force 8.03. So now I have to simply sin theta is equal to sine 105 times 4 over 8.03. So which is gonna give me, let's see, 105 sine times 4 equal to this one divided by 8.03 is equal to 0.4812. So 0.4812. So theta is going to be sine inverse 0.4812. So let's find out that one. Shift it first. 0.4 0.4812 sine inverse. It's going to be 28.8 degree. 28.8 degrees. So we have to carefully read the question. So the question is asking, determine the magnitude of the resultant force F1 and either it directs a measured clockwise from the positive u axis. So they are asking the angle from this u axis. So in order to do that, now I have calculated the clockwise and they are asking it's clockwise. So I have calculated this from this to this. So since this is 28.8 degree, it's little bit below than u, but I have to know to find exactly how below it is. I have to just simply deduct from 30. So if I deduct from 30, theta prime is going to be what? Let's say that is theta prime. That makes from u. So theta prime is going to be 30 minus 28.8 degree. So 30 minus 28.8 degree is going to be 1.2 degree. So that's our final answer. So final answer is resultant force is 8.03 kilonewton and theta prime is going to be 1.2 degree. That's our final answer. So let's move to the next question. The next question is asking 2 point oh, let's see here. Here we go. This plate is subject to the two forces at A and B as shown. If the theta is equal to 60 degree, determine the magnitude of the resultant of these two forces and its direction measured clockwise from the horizontal. So the diagram is given. Let's draw the diagram first. So the diagram right here and straight line, and the theta is here, and the theta is given is 60 degree. 60 degree, and Fa is equal to 8 kilonewton, and Fb is equal to 6 kilonewton, and this is 40 degree. This is 40 degree. So since this is the middle part is straight line, we know that if this is 60 degree, this is 30 degree, and the bottom part is given 40 degree, so therefore this should be 50 degree. So we know the total degree of the angle that making with the forces is 80 degree. Therefore we know we have to first make the parallelogram right here, and we know according to the parallelogram law, the both side is equal to, should make 180 degrees. So we know this one is 80 degrees, therefore the other side should be 100 degree, that is opposite to the resultant force. So since we have found this one, we are ready to use the cosine law. So cosine law is going to be Fr is equal to square root of 6 square plus 8 square minus 2 times 6 times 8 cos 100. So 6 square is 36, 8 square is 64, and minus 6 times 2 is going to be 12, 12 times 8 is 96 cos 100, and 36 plus 6 is 64 is 100, and 96 cos 100, we had to use a calculator to find that. 96, first let's find the cos 100. Cos 100, okay, 100 cos times 96, which is going to be 16.67. So negative 16.67. Since this is the case, 100, so minus minus is going to be plus, minus, so therefore 100 plus 16.67, so it's going to be 116.67, 116.67, and if I square root it, let's see what I get. So to do that, okay, 116.67 square root, so it's going to be 10.8 kilonewton, 10.8 kilonewton, right? So this is the resultant force. So from this one, using this one, I can find the resultant angle that makes this one. So let's say this is the resultant force, and this is the theta. So to find the theta, I can use sine theta. Sine theta over the opposite side is going to be whatever the parallel to this side. So this is 8 kilonewton. So this is parallel to this. So I'm going to use the 8 right here, and this is going to be sine 100 over the resultant force 10.8 kilonewton. So sine theta is going to be this one multiplied by that one. 8 over 1, no, 10.8. So let's plug it in the calculator. So sine 100 sine 0.99, whatever it is, multiply 8 and divided by 10.8 is equal to 0.7295. So 0.7295. So since we have find the sine theta, theta is going to be sine inverse this number, 0.7295. So if I do that, let's see what I get. So let's first shift it, and 0.7295 sine inverse is going to be given 46.8 degree. So 46.8 degree is the angle that makes it the resultant force. So we had to carefully read the question right now. So the plate is subject to the two forces, and A and B as shown. When if theta is 6 degree, determine the magnitude of resultant force of these forces and its direction measured clockwise from the horizontal. So they are asking clockwise from the horizontal. So since the theta is, we found the total theta that makes with this line, right? So in order to find the exact point that makes the horizontal, I had to know exactly where the resultant force come from. So we calculated with whole angle that makes with the this force. So in order to do that, I had to deduct this 51, like I have to deduct this 46.8 from this 50. Then only I will know exactly where it's from horizontal this resultant force is making. So in order to that, let's say that is theta prime. Theta prime is going to be 50 minus 46.8 degree. So which is going to give me what? 50 minus 46.8, which is going to be 3.2 degree. So this is our final answer for that question, and we are done with the question. Let's go to the next question. So the next question is asking, determine the angle of theta for connecting member A to the plate so that the resultant forces FA and FB is directed horizontally to the right. Also, what is the magnitude of the resultant force? So since this case, they are giving the same diagram, but in this time they say theta is not given, like we have to find the theta. Therefore, let's see what can we do with us. So in this case, they are saying consider this as a resultant force, and they are given the same thing right here, and they are saying theta is not given this time. So we have to find the theta. Let's say this is 90 minus theta, and the bottom is 40 degree given, so we know this is 50, and we have to, let's say, draw the parallelogram and make this one, this is our resultant force, and like this, and this is our FR, and according to this first and we know the forces A is FA is equal to 8 kilonewton and FB is equal to 6 kilonewton. So we can use this to find this angle. So first of all, I can use sine law to find this angle. So sine law, let's say sine 90 minus theta over the angle, the opposite force directed to this is 6 kilonewton, because it's parallel to this, right? So this is 6 kilonewton. I'm going to write it in the bottom, and the angle that opposite, because according to the angle, if you know, if you see something like Z diagram, like Z gonna be whatever the angle that make the C is gonna be equal to both, like it's gonna be equal. So here we know it's 50 degrees, so here it's going to be 50 degree too. So therefore we know that's 50 degrees, so I'm going to do sine 50 degree, sine 50 degree, and over whatever the opposite of the force opposite to that. So if you see the 8 kilonewton is opposite to this angle, so therefore I'm going to put the 8 kilonewton right here. So now I can find the sine 90 minus theta. So this is going to give me what, sine 50 over 8 multiplied by 6. So sine 50, we have to plug it in the calculator and see what happens. So since this case, I have to shift it. 50 sine is going to 0.7, whatever the number is, multiplied by 6, divided by 8, and you get 0.5745 degree, 0.5745, so right, 0.5745. So since we have find the sine 90 minus theta, to find 90 minus theta, I have to just inverse it. So 90 minus theta is going to be sine inverse 0.5745. So let's see what happens right here. So if I plug this one, 0.5745, and if I sine inverse it, it's going to be 35.1 degree. So 35.1 degree is the top 90 minus theta. So this is going to be 35.1 degree. If this is 35.1 degree, we can answer the first question, because the first question is asking what is the theta. So we have found the 90 minus theta. So if the 90 minus theta is 35.1 degrees, so let's simply, to find the theta, I have to simply deduct the 35.1 from 90 degree. So let's do that. So theta is going to be equal to 90 minus 35.1. So since this is true, let's plug it in the calculator. 90 minus 35.1, which is equal to 54.9. This is the answer for the first question. So second question is, what is the resultant force in this case? So we know this is 35.1 degree and this is 50 degree. So 50 degree plus 35.1 degree is going to be 85.1 degree. According to the parallelogram law, we know that the angle in the if in the parallelogram, two sides of the angle should be equal to 180 degree. So in this case, I have found one side is 85.1 degree. So to find the other side, I have to simply deduct this angle from the 180 degree. So 180 minus 35.1 degrees is going to be what? One, wait a minute. 180 minutes, okay. 180 and 35.1 plus 850, so 85.1 degree. So 180 minus 85.1 degree. 85.1 degree. So this is going to give me 94.9 degree. So this angle is 94.9 degree. So since we have found this angle, it's easy to use the cosine law right now, because we know the angle that opposite to the resultant force. So let's do that. Fr is equal to the angle that makes the resultant force is going to be what? 6 square plus 8 square minus 2 times 6 times 8 cos 94.9 degree. So let's put it all in the square root. So this is going to be what? 6 square is going to be 36 plus the 8 square is going to be 64 minus 2 times 6 is going to be 12. 12 times 8 is going to be 96 cos 94.9 degree, and 36 plus 64 is going to be 100. 100 minus 96. Let's plug this in the calculator and see what happens. And in this case 94 point, let's see, 94.9 cos. So it's whatever some negative numbers are coming here, so I'm just simply going to multiply with 96. 96. So since this is 96, if I multiply by 96, it's going to be 8.2. So it's minus 8.2. Since this is minus 8.2, minus minus will become plus, and it's going to be 108.2. So to find, let's find the square root of it. Square root of it, 108.2 square root is going to be 10.4. 10.4 kilonewton. This is our final answer. So we have done all the question. I hope you guys enjoy this video. See you next time.